Hello everyone. This video is a demonstration of the concept of triangulation and its usage in structural systems. For this, we will use a molar structural kit, which is a kit comprising of magnetized parts that can be used to create a simulation of structural behavior of framed structures. We will start with making a simple rectangular frame with two columns and a beam. You can see the deformation and the eventual failure in the system even when a little force is applied on it in the way it is shown in the diagram. This is happening partly because the joints that you see here are also almost completely free or mobile in all the directions, and they do not provide any kind of support. These joints can be called as pin joints. Now, let us see how a triangular frame would behave in a similar situation. We can see that the triangular frame is much more sturdy and stable as compared to the rectangular frame, even with the same kind of joints. Now, we will try to see the behavior of a three-dimensional rectangular frame structure with four columns and four beams. Here as well, you can see that even when now it is a three-dimensional structure, it is hardly more stable than what we saw in the rectangular frame. It is liable to fail in all the directions, and also when the force is applied in a specific direction, one can also see torsion. I hope you can imagine from the last discussion, just the previous one, that if these joints were rigid joints, then the support would have been better and the structure would have been slightly more stable. But apart from just making the joints rigid, let us see how the idea of triangulation helps to make the structure more stable and better. Here, you can see that the structure is much more stable than the three-dimensional rectangular frame, and it can sustain its form and stability under forces from various directions. This brings us to a conclusion that triangular shapes and forms are inherently more stable than rectangular or quadrilateral based forms and shapes. Let us see if this newly discovered knowledge of ours can be applied to the rectangular frames to make them more stable. In the rectangular frame we had made earlier, we will add a diagonal member connecting the two junctions. You can see that by addition of a diagonal member, the stability of the frame has remarkably increased and it can now take loads much more efficiently than before. Such members are called tie or bracings. You must notice that by adding a bracing, we have created two triangles within one rectangular frame, and that is what is giving it the stability that it needed. The addition of another bracing further reinforces the stability. The decision of whether you want to use one bracing or two is dependent on the amount of load that the structure needs to take. This precisely is the idea or concept of triangulation that we use to make frame structures more stable. By creating triangles within a structural system, a higher level of stability can be achieved. You can see here that by adding smaller triangles as compared to tie or bracings, we can give the frame a certain degree of stability, although not as much as tie or bracings. Such smaller triangulations are called buttresses and brackets. The lower ones are called buttresses and the ones above are called brackets. Here are some examples. You can see the formation of triangle here as well in these buttresses which make these triangles to take the load of the wall, or in the other case the load of the wall of a dam directly to the ground. You can see the formation of triangle in these brackets as they take the load of the cantilevered structure to the wall and eventually to the ground. Now Let us see if the triangulation can help the cause with a three-dimensional rectangular form or a cuboidal form. You can see that bracings have been added on all the diagonals on the faces of the cube, which has made it extremely stable now. Like the rectangular frame, we will now remove all the bracings and add buttresses and brackets to see its structural behavior. Here as well, you can see that the brackets and bracings can also increase the stability of a structural system, although not as much as bracings. In the end, we can conclude that by adding triangles to a framed structural system in the form of bracings, brackets, and buttresses, it can be made much more stable and sturdy in order to take the desired load. One should also keep in mind that instead of using the systems of bracketing, buttressing, and bracing in isolation, they can also be used together in a composite form to create or to give a structural system the desired amount of stability.